All right, so here we have a Windows workstation set up that has all of the user documents and the user account actually saved on a CEFS protected uh, file server. And here on this screen, we're just going to make some edits to a text file. And this file obviously sits on this particular server that is well, let's make sure the file is saved. And we can see that this is sitting here on the saf's partition. Now, as we look at the file here, we can see that the content is identical to the one that we just edited on the Windows side. So switching back to the Windows side, the content is obviously identical. And what we are going to concentrate right now is on literally running a payload, a ransomware payload that we assume has already gotten so deep that it actually has access to the backend file server. And we can run the ransomware payload on the file server with full super user access. And we're going to literally target the demo user. So not just only on the Windows side, we can literally assume that someone has gotten so deep that they can get back into the file server itself, and that's where they're actually making able to attack. Obviously, this particular ransomware, we just wanted to make sure that it was running the attack properly and on the correct partition, because you should never ever try that at home. This was done by professionals on a closed course. So let's just look at a random PowerPoint, and we see that there's now a ransomware packet message saying, "Oh wow, please give us our Bitcoin before you can get access to all this data." So as the attack is occurring, on the bottom left, if you can see, the attack is still happening, and we can see the files are changing on the Windows side, and they're basically losing the content. And this is just done as part of being able to demonstrate that files can go under a complete attack. And there's no backup, obviously. There's no EDR running on this Windows system. There is nothing else that's available from where to get these files. But we can actually have CEFS eventually trigger the files to recover themselves. So here, let's actually cause the files to do a self-recovery. There's a little bit of a typo here, that's not the way to do it. It's actually getting the actual it's better to actually get the device, not the partition where it's mounted. So we see that there's now 86 memory points. There's that, and some of them have got created just recently. So we see that there's now 86 memory points. There's that, and some of them have got created just recently. So we want the files to basically go back and recall themselves from a time and place. Maybe go down a little bit more. 55, 56, 57, 58, 59. 59 I think is about right. Yeah, let's do it from 59. All right. Please shut down. So obviously the files will say, "Hey, we're being used. Shut down the appropriate things. Samba is running, so we'll shut that down. Do the restore." It's going to wait for the system to kind of synchronize and then get all the files to recover themselves appropriately. It uses the rsync protocol to pull the memories back out. And that's about it. And we just restart the service and go back to the Windows world. And here we are. And all the files should be restored. We should definitely go have a look at all our files. Let's pick up our text file again and see if the file is back. Yep, that data is back. And all is well in the world.